Hi everyone, welcome back to Chem Help ASAP. Today we are going to try to pin down those pesky electrons. So let's start with Werner Heisenberg, who asked the question, where is the electron? And what he found was that you could know the position of the electron really well, but that meant you didn't know its momentum very well. Or you could know its momentum really well, but that meant you didn't know its position so great. This came to be known as the Heisenberg Uncertainty Principle. He actually published this in 1927. So he said, look, you can know one or the other really well, but you can't know both really well about the electron. However, this did not deter scientists. We still have questions. One of these scientists was Louis de Broglie, and he wanted to explain why electrons don't just collapse into the nucleus. Because you have a negatively charged electron, a positively charged nucleus, how can these orbitals be so stable? So in 1924, he had a radical idea. He proposed that the electron acted not just like a particle, but also like a wave. Now, saying that a particle can also act like a wave rocked the scientific community. However, there were many scientists who were very excited about this and were ready to prove de Broglie correct through mathematics. One of the most famous of these scientists was Erwin Schrodinger, who proposed his most famous Schrodinger's equation. Now, the psi in this equation actually is the wave function for the electron. Now, what that gives us practically is psi squared, which is the probability function for the electron. Now, when you solve this equation mathematically, and don't worry, we are not going to solve it here, what you get is you get probability functions for all of the different orbitals in the atom. Now, you might be saying, what is a probability function? So let's figure out maybe what my probability function is during the day. So here is a theoretical map that shows my home, where I work, and let's add in the grocery store just for a little variety. Early in the morning, if you were to take my position, you would find me mostly at home. So you would get multiple data points of me at home. Let's say you move a little later in the day. Now you're going to find just a couple of data points, maybe on the road as I am on the way to work, and then multiple data points at work. Now let's go to perhaps later in the afternoon. I've spent more time at work, but I have also gone now to the grocery store. So again, you might get a few data points on the road and several data points at the grocery store. Then in the evening, I would be spending more time at home. Again, there would be more data points for me at home, and then my day would end. So if we were to plot using spheres how much time I spent at home, work, and the grocery store, you might see something like this. This would be my probability function for the day. This is the same thing that we do with electrons. And what it does is it shows us these very cool pictures of the probability of finding electrons in different orbitals. And you can see that these pictures are not the circular orbitals that Bohr actually proposed. They look very, very different. Schrodinger's equation also gives us quantum numbers, n, L, m sub L, and a little bit later m sub s was added. Using these numbers, we can actually show where an electron is in an atom, which is a very powerful tool. Now, solving Schrodinger's equation doesn't work so well for a t-shirt, but it does help us understand the true nature of the atom. Thanks so much for watching.